All right, guys, it is literally 8 o'clock the night that my son was diagnosed with COVID, but I'm so paranoid that I'm going to get sick that I'm trying to make all the videos for the next 3 weeks. So this is the last one I'm doing tonight. We are doing law of sines and cosines, and what I have today is sorry, I'm not on the first page. There we go. Is the application notes, okay? So what I'm going to do is I'm going to either set up or solve the first like 8 or 10 of these, okay? 2 radar stations are located 20 miles apart, and they both detect a UFO in between them somewhere. The angle of elevation from the first to the station, first station is 35 degrees and the second is 15 degrees. What is the altitude of the UFO? We did a question like this in the notes on law of sines. This is a 2-step process. You have to first treat this as one giant triangle because this does not split this evenly. You have no idea. All you know is this is a total of 20 down here. But if you have a 15 and a 35, let's see, 35, 45, 50, that makes this a 130 degree angle. So we can find one of these missing lengths, and it doesn't matter which. I'll pick this one this time. So the sine of 15 degrees is across from x in the same way the sine of 130 degrees is across, that says 130, sorry. Ugh, it's not going to be that kind of night, is it? I'm trying to get this done. In the same way 130 is across from 20. So I'm going to type 20 times the sine of 15, making sure I'm in degree mode. And then divide that by the sine of 30, 130. And that tells me that this distance x, which was here, was 6.76. So what we're really trying to find, though, is this height straight down. If we know this is 6.76 and this is 35 degrees, by the way, straight down does not split that 130 degree angle evenly either. But we can now use either law of sines with a 90, or we can just use SOHCAHTOA here. This is opposite and hypotenuse. So we have the sine of 35 equals opposite over hypotenuse. So if we type the sine of 35 times 6.76, we get 3.88 or 3.9 as the height. And it was miles. All right, 2 steps. So be careful. There'll probably be another one like that somewhere. This is super easy. I'm really not even going to set this one up for you, but it says the boat turned 20 degrees here, guys, and this is a straight line. I'm going to exaggerate the picture just a little bit. So it was going straight, and it turned 20 degrees here. Remember your geometry? A straight line's 180. So 180 minus 20 is 160 degrees. So in that triangle, you have 8 miles here, 160 degrees here, and 10 miles here. And you want to find the distance they are apart. So you're just going to do law of cosines. So the trick to that was just that a straight line minus 20 would be a 160 degree angle in there. So you need to type that all in and then take the square root. All right, now we're going to talk about bearings questions. These are tricky. This question, okay, it says a bearing measures the acute angle that a path or line of sight makes with a fixed north-south line. So we're always going to measure off of this north-south line, okay? Either towards the east this way, towards the west this way. So we have west, east, north, south. Okay. The other thing we need for this particular question, this one's really tricky, is rate times time equals distance. It says 2 ships leave a port at 8 a.m. A ship A sails with a bearing of blah, blah, blah at 17 miles an hour. So its rate is 17 for ship A. And ship B is a bearing of blah, blah, blah at a speed of 12. And their paths continue. How far apart are they at 2 p.m.? So from 8 a.m. here to 2 p.m. is 6 hours, right? Yes, 6 hours. So if we do time is 6 hours for both of these, 12 times 6 is 72 miles this ship has gone, and 17 times 6 is 102 miles this ship has gone. I'm not sure I gave you more of those, but so now we got to figure out this drawing. 2 ships, A is sailing at a bearing of off of north 68 degrees towards the west. So here's our north-south line, and he is going 68, which is over half, right? Towards the east. Off of north 68 degrees towards the east, it says. They're always measured off of north-south according to this. And that is ship A. And ship A was 102 miles, it says here, according to our calculations. Okay. Ship B sails with a bearing of south 35 degrees east at a speed of 12. If the ships maintain their paths, how far apart will they be? They leave the same port, okay? So they both left here. This guy went 102 this way. Ship B is sailing, instead of going straight south, so this was off of north, this one is off of south, he's going 35 towards the east. And he is ship B, and so his path is only 72 miles long. I can try to erase a little of that, make it shorter. All right, so he's gone to here. We're trying to figure out how far apart they are. So we can find this angle in here because all of this has to make 180 from this north-south line. So if we do 180 minus 68 and 35, we get 77 degrees in here. And then all you have for this problem is 77 degrees, 102, and 72, and you're trying to find this. So that's a straight up law of cosines. So 72 squared plus 102 squared minus 2 times 72 times 102 times the cosine of 77. Don't push enter in there anywhere. And then you get x squared. And then you need to square root that. And I got 124.2 roughly. Which is not what I have on my paper here. Let me type it one more time. I have all the numbers right. (72) squared, I wonder if I typed 120 somewhere on the other one, plus 102 squared minus 2 times 72 times 102, all times the cosine of 77. Don't hit enter along the way. Nope, I got a different number this time. What did I type wrong? Wow, I can't even see what I did wrong. But this time when I typed it, I got 12283.9, which matches my notes. And then when I square root that number, I get 110.8, which is what I had in my notes. But I'm just looking at the calculator and I can't figure out what I typed wrong. Oh, instead of a times in one of these, I had a minus. Yeah, okay, anyway. I'm just gonna set this one up with you and then let you finish. Michael leaves home and drives 17 miles to work. After work, he travels 9 miles to a friend's house. If the bearing from work to the friend's house is south 24 east, find the distance from the friend's house, between the friend's house and home. Okay, he drives straight west. That's what we need to know first. 17 miles from home to work. After work, he, instead of going north or south, says he drives 9 miles to a friend's house if the bearing to the friend's house is off of south 24 degrees towards the east. Okay, 24 degrees towards the east. And again, he went 9 miles that way. Well, this whole thing has to be 180, but better yet, if this was straight east-west, this is a 90. So if we do 90 minus 24, we get 66. So here's the triangle. Well, I could at least make it look like east-west. 17, 66, and 9. And how far is he from home? So that's just a law of cosines question again, okay? X squared equals 17 squared plus 9 squared, blah, 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 blah. I'll let you finish that one, and the notes will be on the answer key. You can check your work. This one, I wrote down that I should just set this up, that you should be able to do the rest. Okay, this was kind of bothering me when I read all this, and then I figured out it has to be an obtuse angle. Okay, 2 trucks 36 feet apart are towing a large field mower. So there's this big mower out here. If the 2 ropes are 27 and 19, okay, mine look the same, but find the angle formed by the 2 tow ropes. So that's this angle. So this is just a law of cosines question where the opposite is 36 and the adjacents are 27 and 19. It's 2 times 19 times 27 times the cosine of the angle. So you're going to have to work backwards to find that angle. I called it theta one place and x another. Sorry, that's not good practice, but a fireman spots a stranded woman, okay, in the window of a 200-meter tall, so this is 200 foot tall, I can read. She is in a window up here. Point where the fireman is standing, the angle of elevation to the woman. So where he's standing, he has to look up to the woman. 42 degrees and 33 minutes. I picked this because I think I did in a lesson how to change this to a decimal, but minutes are 60ths of a degree. So this is 42 plus 33 60ths. which is 42.55. Okay. He also, though, he looks to the top of the building. So from his eyeballs right here up to the top of the building, big dot, is 58 and 6 minutes. 58 plus 6/60ths, which is 58.1. So this big green angle here is 58.1 degrees. All right, what we need to do is figure out how far from the ground is the woman. So we need this distance right here, this little X. How far up is she? I think this is a two-stepper, like the blimp question in the notes and the, what was the other one we just set up a minute ago? The UFOs, but it's drawn differently. We know right now that in the red triangle, this is 42.55, and we're trying to find this distance h. But we don't know anything else. In the green triangle, see, the green triangle is golden because 200 is all the way to the top here. So 200 here and 58.1 here. So if we can find like this, I'll call this G for ground. If we can find that ground distance, then we'll be able to find X over here. So I'm going to find this distance the fireman is away from the building first. This is actually a right triangle trig problem. So we have opposite over adjacent, which is tangent. And then if we do 200 times 1 divided by the tangent of 58, 200 divided by the tangent of 58.1, I got that the ground distance here is 124.5. So the fireman is standing 124.5 feet from the building. So now we just need to do one more time here with this triangle. Again, it's opposite and adjacent legs. So we have the tangent of 42.55 equals opposite over adjacent. So 124.5 times the tangent of 42.55 is 114.3 feet. You know what? I think there was another way we could have done this. No? No, I don't think so. Well, there is, but there's nothing that was going to be faster. Okay. All right. Oh, this was a multiple choice question. Did we get one of the answers? Oh, we did. We got B. All right. Because the next two are bearings questions, I was going to give you a little head start on them here, and I'm going to help you set them up, okay? This says a drone is flying over a college campus, and the drone spots the cafeteria on the west end of campus at a 27-degree angle of depression. So that is also the angle down here. And the sports complex on the east end of campus, oops, at a more steep angle. I made it look. Yeah, the drone has to look down 34 degrees there, which means here it would be a 34-degree angle with the horizon here. And they are separated by a straight road that is 2.3 meters high. Or long. How high is the drone? Okay, this is just like number 1 on the front. So, yes, example 1 with the UFO. So I'm going to let you do that one. And this one has us using bearings again, so I was going to help you out. Two towers at a national park spot a forest fire. Tower A spots the fire at a bearing of north, off of north. He has to look 38 degrees towards the west to see the fire. And that was Tower A. Spots the fire. If Tower A is 729 meters directly east of Tower B, so, oh, he's east. I'm going the wrong way. So Tower B is over here to the west, right? Tower A is directly east. There we go. Find the distance of each to the tower. Okay, Tower B spots the fire. I didn't read this very well here. Here's the north-south line that goes through Tower B, and he spots the tower, the fire. The fire is out here somewhere. I should make it red, I guess. Flames. I don't know how you draw flames. I'm doing a really bad job of it. He spots it off of north. He would go towards the east, 48 degrees to be able to see that. All right. The issue is that these are both 90-degree angles here because this was an east-west line and this is a north-south line. So 90 minus 48 is 42. And 90 minus 38 is 52. Make sure I did those right. Okay. So if we wanted to add the triangle up, let's see, we're at 94. So this would be an 86-degree angle up here. And this is 729 meters. So there's your triangle. 42, 86, 52, and 729. Now, be careful because this is Tower A, so this is actually the distance from A. So I'm going to call that little a, even though it's not a cross, okay? This is the distance from A. If this is Tower B to the fire, which is up here, okay? The distance from B to the fire, if I call that, would be this side, okay? So we have distance from B, and that would be little b, and distance from A, and that would be little a, the way I labeled it. But you're just going to do law of sines. You can find these, okay? I think I am done. You guys have 4 more questions on the back that are all multiple choice, and I think you got this.